Hello friends, welcome back to the channel. This is the second part of Pelton wheel turbine. In our first part, we have discussed the construction and working of this turbine, and in this video we are going to discuss the velocity triangle for this Pelton wheel turbine. So in our previous video, I have shown you the runner, how the working and construction. So in construction we have seen this is a runner, and in the periphery of the runner the buckets are attached, that is blade, or you can say vane are attached. So vane is the shape of a two hemispherical ball like this. Okay, so when you see the blade it will look like this. Okay, this is a splitter. What is the function of a splitter? The splitter divides the jet of water into two equal parts, okay, to go here and here, both the buckets. Now when you cut a cross section here, you will see bucket somewhat like this. Okay, and in previous part I have also told you that the jet of water hits the splitter. Okay, means water enters in the bucket like this, okay. So let this be A, this be B. Okay, so this is the velocity, that is v1. Because we are drawing inlet triangle, so I have used v1. So what is this v1? Is this the absolute velocity, of jet? Okay, this is v1. Now as the vane or blade is also moving with a velocity what, u1, this is velocity of blade, or you can say vane or bucket, whatever you say. Okay, so there is a velocity of blade also. Okay, now both are moving in same direction. Blade is also moving in this direction, jet of water is also moving in this direction. So relative velocity of both will be negative, that is vr1 relative velocity will be equal to v1 minus u1, because v1 and u1 both are in same direction. Okay, so this will be, let this point be C. This will be the relative velocity vr1. Okay, now we know that the absolute velocity has two components. One is horizontal and one is vertical. Horizontal component is vw, that is wall velocity, and vertical component is flow velocity. If this is absolute velocity, it has two components, horizontal and vertical. So in this case, v1 is horizontal. So vertical component will be 0. Means in this case, vf is 0. Means the value of v will be equal to vw1, because this is horizontal. So this will be equal to vw1. Okay, and in this case, this is what, this angle is alpha. Okay, and alpha angle is 0. What is the angle alpha? Alpha is defined as angle between absolute velocity and the direction of velocity of blade, okay, in the inlet triangle, that is alpha. So here vf and alpha is 0. Okay, so v1 will be equal to vw1. And what is vw1? Vw1 is wall velocity at inlet. Okay, so this is inlet triangle, and when you see the outlet triangle, the water enters with vr1 velocity, so it will exit with vr2 velocity. Okay, and there is also a blade velocity of u2. Okay, so I have used in outlet triangle, so I have used u2, and here we have used u1. So this will be, when you join this line, this will be what, this will be v2, the absolute velocity at outlet. Okay, so absolute velocity of jet v1 and v2. V1 is for inlet and v2 is for outlet. Similarly u1 and u2, velocity of blade or vane for inlet and for outlet. Okay, now here again v2 have two components. One is vertical component, the other one is horizontal component, that is vw2, and this will be what, vf2. Okay, now vf2, this is flow velocity at outlet, because in inlet it is 0. vf1 is 0. Okay, now I hope you all know all the variables now. Absolute velocity, velocity of blade, relative velocity, whirl velocity, and this is flow velocity. 2 is the subscript used for outlet and 1 is the subscript used for inlet. Okay, now we have to define 4 angles, that is alpha, beta, theta and phi. Okay, now these are the triangles for absolute velocity, and these are the triangles for relative velocity, angles for relative velocity. Okay, alpha is for inlet, beta is for outlet, theta is for inlet, and phi is for outlet. Okay, so relative velocity, that is the angle made by absolute velocity with u, that is direction of blade, and relative velocity, these are the angle made by relative velocity with u. Okay, so phi is the relative velocity with u for outlet. So relative velocity is vr2 and u is this, so this angle is what? Phi. And for absolute velocity with u, for outlet it is beta. So this is absolute velocity and u direction is this one, so this angle is beta. Okay, and for inlet both the angles are 0. That means for inlet triangle, if you will see, alpha and theta both are equal to 0. Okay, this is a way how to remember, how to study this velocity triangle of Pelton-Wheel turbine. There is a more easier way to study this. Let me explain you that. So this is the velocity triangle of turbine. If you remember this, I've already made a video on this. I will give in the link in the description box below. Please see that. Okay. So if you remember the velocity triangle of turbine, from this you can easily remember the velocity triangle of Pelton-Wheel turbine. Okay. You just have to put the value of alpha, theta, and Vf1 equal to 0. You get the value, you get the velocity triangle for Pelton-Wheel turbine. So if this inlet triangle, for inlet triangle only, okay, if you make alpha, theta and Vf1 0, then you get V1 will be what? Straight line, a horizontal line, this is V1, and U1 is this, U1 is this value, so this will be what? U1, and VR1 will also, as theta is 0, VR1 will be also horizontal, so this is VR1, and this whole is what? VW1, so this is VW1. This will be the inlet triangle. This will be the inlet diagram for Pelton-Wheel turbine. Okay, and outer triangle is same as this. Okay, so if you know this velocity triangle, you can easily remember Pelton-Wheel turbine. Okay, so I hope you got the concept of Pelton-Wheel turbine velocity triangle. If you have any doubts, please comment me and ask the questions. For let us just have a quick review of this. This is outlet triangle, this is inlet triangle. Okay, now it's not a triangle, but you can say, because this is velocity triangle. So inlet, the velocity of jet is v1, that directly hits the splitter. Okay, and velocity of vane is also u1, so I have taken this u1. Relative velocity will be v1 minus u1, because v and u are in same direction. Okay, so this is vr1. So we can say vr1 is equal to v1 minus u1, and the whole velocity will be vw1, because v1 have only horizontal velocity and no vertical velocity. Okay, so vertical velocity vf is 0, so vf for inlet is 0, and alpha is also 0. That's why the v is horizontal only. Okay, now this will define the inlet triangle. So for outlet triangle, this is if it enters with vr1, it will exit with vr2. If there is no losses, then we can say that vr1 will be equal to vr2. If there is no loss here, if a smooth flow is there. So vr2, u2 direction of vane, so the resultant will be what? v2, here v2, and the vertical component and the horizontal component for this. Okay, we have defined 4 angles, that is alpha, beta, theta and phi. Alpha and beta, inlet and outlet triangle, inlet and outlet angles, inlet and outlet angles. Okay, alpha and beta are the angles that absolute velocity made with u, and theta and phi are the angles that relative velocity made with u. Okay, so I hope you got this figure. Thank you. See you in next video.